In this lesson, we're going to do hypothesis tests for the difference between two means, and we're going to do paired samples. And if you look at this first problem, it says a sample of 8 automobiles were run to determine their mileage in miles per gallon. Then each car was given a tune-up and given again to measure the mileage a second time. So if you notice, I've got 8 cars after and before. This is match pairs. We're going to match each car with itself. So like we're going to compare car 7 to car 7, and we're only going to look at the differences. These are paired samples because each value before tune-up is paired with a value from the same car after tune-up. When we have paired samples, the pairs are called match pairs. By computing the difference between the values in the match pair, we construct a sample of differences. And if you look at what they've done here, they've done the differences. And then that's all we're going to look at. And we're going to do a one sample T with only the differences, like what we did in the confidence interval. The notation that your book uses that I like is the D bar. It's the mean of the differences, the sample mean. SD, it's a standard deviation of the differences. And mu of D is the population mean of the differences, which is what we're aiming for. Now, the conditions on this are easy. It's only the two. I need my SRS, and I need to satisfy my normal condition by one of the 3 ways that are possible. All right, and here's some math behind it. I wanted you to see the formula again. It's the same formula we did before. It's exactly the same, except it has that D bar in it instead of X bar. Other than that, it's the same thing, S of D instead of S. Now, here's the problem. And notice that here, they've only given you the differences because that's all I need. It's the same problem as before. And it says, I want to test HO and the mu of D is 0. That means there's no difference. Versus H1, mu of D is greater than 0. H1 sometimes in this is a little tricky to get, so you want to be careful. I'm going to show you a couple that will help you on this. But when you look back at this, the way they subtracted the differences, when you look back here, they did, for the differences, they did after minus before. And why they're trying to see here is if mu of D is greater than 0, is they want to see if this difference is positive. Because if it's positive, like in this first problem, it means the tune-up made a difference. It gave you better gas mileage. And if you look at all of them, they're all positive. The gas mileage improved in every single car. All right, so what we're going to do, my conditions, I'm going to do SRS check and type in your data in the calculator. So I'm going to go to my first one. And I'm going to clear out this second one also, just so it doesn't try to graph that one. All right, so I'm going to go to my first one, and I'm going to type 1.68, type all your data in. All right, and I'm going to graph it, box plot, and as always, it's going to look fine. So here is my box plot. And I'm going to say no outliers, normal, check. They gave me my H of O. Mu of D is 0. My H of 1, mu of D is greater than 0. I'm going to go to my tests. I'm going to do my inference. I'm going to go all the way back. I'm doing one mean this time. I'm doing a t-test. My HO is mu is 0. There's no difference. My alternate is, yeah, there's a difference. It's now greater than 0. The difference is greater than 0. So the tune-ups made a difference. It made it better. I'm going to use a data set. It's going to automatically, notice that's pulling up V1. That's all we have in there. And I'm going to go, there is my answer. Now, what I'm going to get for this answer, here's my screenshot. I did a 1 sample T. My T is 9.143. My p-value, I'm going to write up here. My p-value is 1.925. I've got some more numbers and then e -5. That scientific notation for very small, move the decimal 5 places to the left. So I'm going to have to add 4 zeros. 0.123411925. Double check yourself. 1, 2, 3, 4, 5. I'm going to round my p-value. Anytime you have that e -5, it's very small. I'm going to round my p-value to 0.0001. So very small p-value. If that had been e -13, I would have just put 0 as my p-value. My p-value is small. My significance level was very small, but my p-value is smaller. So if the p-value is low, HO is going to go. So I'm going to say since our p-value of 0.0001 is less than alpha equals 0.01, we will reject HO. We have enough evidence to conclude the true mean difference is greater than 0. And I just went right to H1 to get that conclusion. In other words, the gas mileage improved. All right, and for my interpret, I'm going to say if HO is true, there is a 0.0001 chance of a test statistic as extreme or more extreme than ours. T equals 9.143. And what I want you to look at with this one, I'm just going to talk about how to set it up. We're not going to actually do this one, but I want you to look at it because this is the part on ALEKS sometimes it's going to be hard. It says, following are the annual amounts of rainfall in inches in 6 randomly chosen cities for 2 consecutive years. Can you conclude that the mean rainfall was greater in year 2 than in year 1 at the alpha equals 0.05 level? Now, here's what I'm going to do. I would have to do the differences. So we know that I'd have to do all the differences. I'm not going to do the whole problem, so I'm just going to do the first one. All right, so here is my first difference. Now, when you're doing this problem, here's what you're going to do. You're going to do your conditions like normal. When I test the conditions, I'm only going to look at this bottom row. Here's going to be my HO. My H1 is going to be, can you conclude that the mean rainfall was greater in year 2 than in year 1? All right, so now just because this says greater, it is not always a greater than sign. Okay, so here's what I'm going to do. I'm going to look at the difference. I'm going to do HO. I'm going to say HO is always mu of D equals 0 in these problems. There's no difference. Now, I want you to look at one where it was greater in year 2. So like this first one. Okay, if it was greater in year 2 than in year 1, I got a positive answer. All right, if I get a positive answer, a positive number is greater than 0. This is going to be greater than 0. And like I said, just because this says greater, it's not always greater in these problems. You need to look at your difference and you need to be careful. Now, the next one that we're going to do. So we're not going to do that one. We're just going to look at it. What I want to do on this next one All right, it's same type problem. I can tell it's matched pairs. I've got 9 autos. The mileage of what the original front brake pads were worn to 10% of their original thickness was measured, as was the mileage of the original rear brake pads, and the results are given. And it says, can you conclude that the mean time for the rear brake pads to wear out is longer than the mean time for the front pads? Use the alpha equals 0.05 significance level. All right, so what we're going to do, pause the video and find all of your differences. And what I'm going to do is rear minus front. So everybody pause and then come back on once you've subtracted them. Once you've entered your, once you've got your differences, check them with mine, enter them in the calculator, just the differences. Once you've done that, turn the video back on. Our conditions are going to be SRS. I'm going to go to my statistics. I've entered my data. I'm going to graph it, box plot. There's my box plot. No outliers. Normal check. Now, when you do your HO and your H1, it says for H1, can you conclude that the mean time for the rear brake pads to wear out is longer than the mean time for the front pads? Okay, so look for one of your answers where the rear was longer than the front. Okay, I don't have to look far because it looks like they're all like that. So here, I'm going to look at first one. Rear was longer than the front. 9.9 is positive, so that's going to be greater than 0. If 9.9 had been negative, I would have said less than 0, if that had been the case. All right, so I'm going to do for H1, mu of D is greater than 0. HO, mu of D is 0. Mu of D is greater than 0 because the rear is more. When you subtract it, it's going to be positive. And like I said, you got to think about that sometimes. I'm going to go to my inference. I'm going to do a test. I'm going to do one mean, t-test. My null is 0. My alternate is greater than 0. And I'm going to pull in my data set. And it's a 0.05 level. Now, look at your test statistic, how far out that is. All right, so here is my answer. I did a 1 sample t-test. My t is 60.277. And my p-value is very small. E negative 12, you'd have to move the decimal 12 places. You'd have to add 11 zeros. So here's what I'm going to say for P. You could say it equals 0. I don't like to say it's exactly equal to 0, so I'm going to say it's approximately 0. But if you said equal, it would be fine. P-value is very low. HO is going to go. All right, so I'm going to say, since my p-value of approximately 0 is less than alpha equals 0.05, we will reject HO. HO is gone. We have enough evidence to conclude the true mean time for the rear brake pads to wear out is longer than the front. The true mean time for rear brake pads to wear out is longer than the front. And lastly, I'm going to say, for my p-value, I'm going to say if HO is true, there is a approximately 0% chance of a test statistic as extreme or more extreme than ours. And ours is T equals 60.277. And that's it for matched pairs.